basic concept of crystal structure, where we're gonna talk about 7 lattice system, periodic array of atoms, solid, types of crystal, molecular solid. So these are the 7 lattice system: the monoclinic, the orthorhombic, the trigonal, cubic, triclinic, rhombohedral, and hexagonal. What is a crystallographic axis? It refers to the axis in order of A, B, and C. The point of the intersection of the three axes are called axial cross. Axial angle represents alpha, beta, and gamma, where A to B is equals to gamma, where gamma is the angle, A to C is equals to beta, where beta is the angle, and B to C equals to alpha, where alpha is the angle. Cubic system, also called as isometric system, where the unit cell is in the shape of cube. This is one of the common and simplest shape found in the crystal and mineral. Its crystallographic axis is equals to A equals to B equals to C, where all A, B, and C are equal, and its axial angle is alpha is equals to beta equals to gamma is equals to 90 degrees, or a right angle. They are all equal to 90 degrees. The trigonal system. The trigonal system has 3 axes, and they also meet at 90 degrees. The only difference is that C axis is longer than A and B, where you can say that A is equals to B, but A and B are not equal to C. Its axial angle is equals to 90 degrees, where alpha equals to beta equals to gamma. Orthorhombic system is a type of crystal structure where lattice consists of 3 axes that are perpendicular to each other and whose length may or not be inconsistent. So it is inconsistent in length. So A, B, and C are not equal to each other, but their axial angle is equal to 90 degrees. Monoclinic system is a crystal system refers to 3 axes which is have an equal length, A, B, and C, but B and C are not perpendicular to each other. So A, B, and C are not equal in length, but their angle alpha and gamma are equal to 90 degrees, but beta is not equal to 90 degrees. Hexagonal system. It has 4 axes in which 3 axes follow the same plane and intersect at the axial cross at 120 degrees, where A equals to B but they are not equal to C. The axial angle is that alpha is equals to beta equals to 90 degrees and gamma is equals to 120 degrees. Rhombohedral system, a crystal system characterized by 3 equal and interchangeable axes at equal angle to each other and usually classes as a division of a hexagonal system compared to tetragonal system. So A is equals to B equals to C. So all lengths are equal, but their axial angle is not equal to 90 degrees. Tricyclic system. A crystal system refers to 3 axes of which unequal lengths that are inclined, not perpendicular, at angle relatives to each other. So A, B, and C are not equal, and the alpha, beta, and gamma are not equal to 90 degrees. This is the formula where A, B, and C are not equal, and alpha, beta, and gamma are not equal to 90 degrees. Periodic array of atoms. There's a serious study of solid-state physics began with the discovery of X-ray diffraction of crystal and the publication of series of a simple calculation of a property of crystal and electrons in crystal. So as you can see in the image, using X-ray diffraction, they are able to see and calculate the properties of the crystal. So X-ray diffraction, or XRD, is a rapid analytical technique primarily used for phase identification of crystalline material and can provide information of unit cell dimension that analyze the material in fine ground, homogenized, average bulk composition is determined. So as you can see in the image, this is how X-ray diffraction works. We're going to move about the structure of crystal. A crystal is a solid in which constituent atoms, molecules, or ions are packed in a regular fashion, repeating pattern extending all three spatial dimensions. A crystal is a mathematical description of repeating regular array of atoms, in which it is properly accounted for what is repeating and how is it repeating. So the crystal structure is divided into two. The bases, also called as motifs, are the fundamental repeating units. The lattice is the specified points beneath the bases explaining how the units is repeated for a line. Crystal structure is equal to lattice plus bases. So, as you can see in the image here, this is the repeating object, which you could call basis, and this is the lattice where it has alignment and formation. Space lattice. A group of points in 3 dimensions is arranged in a various pattern, irregular fashion, and the points are called lattice points. The crystal lattice has no significance unless it's filled with atoms or molecules, in which call them bases. So just a quick classification. Previous lattice are the lattice points in a space lattice having the same basis. Non-previous lattice is the lattice point in a space having different bases. So they have different bases at the same basis. So unit cell. A unit cell is the smallest portion of crystal lattice that shows 3-dimensional pattern of the entire crystal. A crystal can be thought as the same unit cell repeated over and over in 3 dimensions. So this is the formula where R is equals to X A1 plus Y A2 plus Z A3. So this is the unit cell. This is the unit cell, and this is the unit cell. As you can see, this square is representing the unit cell, where the whole square covered the crystal structure. There are different types of unit cell. Simple cubic unit cell. A primitive unit cell has an atom at the corner of the cubic. Body-centered cubic unit cell. Body-centered cubic unit cell has a lattice points not only at the corner but also at the center of the cube. Face-centered cubic unit cell has an atom not only in the corner but at the center of each face. Face-centered cubic unit cell, a unit cell that has 2 atoms, one at the upper, one at the lower, along with the corner. So in this image, it represents the types of unit cell, where simple cubic, it has 8 corners. Body-centered cubic, it has 8 corners, but there is a centered atom. Face-centered cubic, it has 8 corners, 6 central atoms. And base-centered cubic unit, it has 8 corners, 1 atom at the upper, 1 atom at the lower. . simple cubic unit cell is equals to 8 times 1/8 equals to 1 atom. So, body centered cubic unit cell, 8 times 1/8 plus the center atom plus 1 equals to 2 atom. Face center cubic unit cell, 8 times 1/8 plus 6 times 1/2 is equals to 4 atoms. Composition of solid. Solids are the state of matters in which atoms or molecules are locked into place by either chemical bond or forces between molecules called intermolecular forces. Solids are usually hard, have a shape that doesn't change, and possess a fixed volume. Classification of solid. Amorphous solid, any non-crystalline solid in which the atoms and molecules are not organized in a definite lattice pattern, such as glass, plastic, and gel. Crystalline solid are atom, ions, and molecules that make up the solid exist in a regular, well-defined arrangement, such as cubic, tetragonal, hexagonal, rhombic, monoclinic, and triclinic. Types of crystal. Ionic crystal. Ionic crystals are created using ionic bond. They are solid crystals with high melting points held together by the attracting ions, positive to negative. Ionic compounds do not conduct electricity as solid but do conduct electricity when molten or an aqueous solution. The most well-known ionic crystal is found in your salt shaker. Metallic crystal. Metallic crystals are made of metals and held together using metallic bond. These crystals have a shiny appearance and include copper, gold, aluminum, and iron, to name a few. They have electrons capable of moving through the entire crystal. As a result, metals are good conductors of electricity. The melting point of metallic crystals span a wide range. Covalent crystal. Covalent crystal are crystals bonded by covalent. These are extremely strong and brittle since atoms shared electrons to create the bonds. They have extremely high melting point and boiling point. Being composed of atoms rather than ions, they do not conduct electricity in any state. Since these diamonds are packed together and covalently bonded, these materials are extremely hard to break, like diamond and quartz. Molecular crystal. The weakest of all crystal and a molecular crystal. Held together by weak hydrogen bond, molecular crystals have low boiling point and break apart relatively easily. Some you could even break apart with your hand. Dry ice is a great example of molecular crystal. You might even find molecular crystal in your pantry in a form of rock candy. A new crystal could be yummy. Yan. Molecular solid. Molecular solid consists of atoms or molecules held together by each other, either dipole-dipole interaction, London dispersion forces, or hydrogen bond, or any combination of these. Because intermolecular interaction in a molecular solid are relatively weak compared to ionic and covalent bond, molecular solids tend to be soft, low melting point, and easily vaporized. Iodine is a volatile molecular crystal. One of the examples is iodine, which are bound by dispersion forces. Due to their weak nature, iodine crystals generate easily visible purple vapor with a strong smell. So that's it all.